Okay, this is an important one, at least in my opinion, to figure out. And I'm going to start by not going too deep into it, but it does build. I've got some cool ways of bringing in and importing things that aren't other people's STLs or OBJ files. And we are going to look a little bit at the protein database online form. I can't remember what the four-letter acronym is for that website, but I'll show that in detail later. Right now, I just want to cover the last bit of these nodes within this primitive section, data path, data, and file path. Then we'll go on the KUKA, PRC, and shader. Basically, what they are is you can take a file path and you can import whatever you want. What I did was I went in and imported pictures of my two kids, one being filed through the data node container, and you have black and white of my son Max and black and white of my son Oscar. Another way they import stuff is to go into image sampler and double click on it and go in and find a file and bring it in. But I'm finding there's always kind of a problem with that. As you look in here, floating parameter image sampler failed to collect data in some situation. And then when I run through while that's there, this file in here, it seems to get rid of that problem. So something's happening with the node. I'm going to go farther in the image sampler and spend a whole section on it when we get into the inputs. So don't worry about that. I'm just showing like how you start to look at data. So what I did for excitement was I went in and I grabbed a data path of a protein database, which I pulled a PDB off of line. And there's thousands of things you can grab. And there is a tool in here called import PDB, and that's what it does. It brings in the file on this end, synchronizes it, and it gives you atoms and bonds. Bonds I don't find much information in, and I pulled this off of some online tutorials. You have data coming in, and you have a lot of data. Actually, I have 965 lists of data in this one protein database. And a good thing to do is go into the atom data, plug it in, and see each bits of data, what's there. And I've gone through each one and seen what has the most variety. Residue numbers, okay, but it's not, it runs through a whole stream of numbers that I pretty much could generate in another way. This one, the same thing. It's just a numbered system of the serial numbers to those points. To that data. This one doesn't have a very high range, 6 to 5, so I'm not going to use atomic number. But temperature definitely is one that's very interesting to look at, but that's a number. What's great is you also have the points, and as you generate the points, there they are. So I took the points as a medium of beginning, and I said, well, there's a list length. Let's divide the list length by 0.1 to 1.1. And don't ask me why I did that math in division. I could have done multiplication, but I did a random reduce. And I have a seed that will actually change that as we go. And you get all these incredible different geometries. And I think that's really the excitement of this. And what I did was I simply went back into how I understand things geometrically, because it's about data visualization for the artist. And I think that's going to play more and more of a role as people working contemporarily in the arts and working as 21st century sculptors. So like I said, this if you dig in, you actually watch my videos, I mean, you're going to find some real secrets and tricks in here that not only have I seen online, but also I've kind of compiled in my own head. And as for this tide or applications to the world, that's you to figure out. That's not me. So basically, I random reduce with a shift list that I did a shift list to. Now, if I shift list here, it's going to change things as well. I've got so many ways to seed this differently. And I pull in a line system and another line system, and you'll see what they are. It's not too hard to figure out. Puts them all together. And I pipe those. And I pipe those differently than I pipe these. And now I'm getting a little lazy because I'm far enough in my scripts and I've shown it enough times so that I'm just grabbing a range and I'm assuming the default domain and the default steps and the default range and default steps. The one thing I've done differently in here is as I go in, I believe I've gone in. No, I haven't changed the range. I could go in, and one thing you do on the graph mapper is you change the range here from its reparameterized 1 through 0. But you end up with some pretty cool geometries, and there they are. Pick one and put on the view, and you've got some pretty cool geometry that you probably never would have made. Now, that's the first half of this, which I think is worth watching this video for. The second half is a little different, and I don't think this matters to look at this visualization, so I'm going to put it over here. I might leave it up just for fun because it is fun to look at. Let's take off this little thing here, and let's look at what I did. Basically, I grabbed domain. I grabbed, okay, a point. And I put it through a data path, and the data path says, okay, you got a path 0 in these curly brackets. Okay, I understand that. What happens when I move that geometry through, if I move it 2 units? Well, then all of a sudden my data path becomes, okay, you got one thing happening here, a line that's 2 units long, and you've got 2 in there, which are 2 points on that line, I assume. It could be 2 units. Then what I'm going to do is I'm going to grab a cylinder, and the cylinder's got 3 components, and I think that's the top, bottom, and the side. When you think about the geometry on a cylinder, So let me jump in here and go in here. Basically, I start to analyze what's happening. And even though the other stuff's there, the points and lines as well, I'm understanding that's 3 going through the data path, what it's telling me. Now, if I take that and I move it in a range of 2 units and I get 3 moves, it's going to say you've got 0, 1, 2. You've got 3 different things happening on a data path that influence 3 pieces of geometry. So you're actually starting to visualize this data, not just through your Param viewers, which is here, and then you actually can go in here and double click and go to the tree view. You're starting to realize, okay, I'm starting to understand why these trees look differently. Sorry, I should do the geometry, and I assume it's going to come up with different tree data, whether I graphed it or not. But right now, I've just got one item with these items on the end of it. So the param viewer isn't telling me as much information as I can call out of this. Now, if I have those 3 and I put it through a 5 rotation, then I'm going to have 5 rotations of those geometries of 3. And what you have then is you go into your set tools and you go in down to this tree information. You see all these things that say paths. It's like, I need to wrap your head around. You have to come to understand these things. So quickest thing I did here was just deconstruct paths. And I pulled that in, and that's exactly what it's doing. It's grafting on the information here, but you'll see it's listing not only what I had here is 3, it's saying, oh, that data path is going to be 3 on there as I go through it. This one's going to come in and say, okay, you got that data on there, but you've got to count that at 000, 001, 002. And you're starting to wrap your head around where this information is. This one has 5 paths for those 3, so it goes all the way up to 005. Now, those are the things that have deconstruct path. What other nodes are in there? Well, they're in there, and we'll go detailed in there when we get there, and I'm going to go back to Daniel Kristev's work on Path Mapper. But when you find out how to script within Path Mapper, which I'm not going to teach right now, and you find out that you can take your source code, you can bring in indices, you can change things and swap data and start dealing in data trees. I don't know if that's Daniel Kristev that does. He does it very well, but also Mode Labs does it incredibly well. And I have tons of videos and tutorials and things that I have on my other areas that highlight that as my learning curve. Now I'm at the point that I've learned it. I've learned the language. I know kind of what they do. How can I apply these to geometries? And that's what this whole series of 1001 scripts is about. It's look at every single node, become familiar with it. Let it not be so alien to you as a language, and start to write your own poetry, write your own songs, write your own music. That's why we're doing this. And it is about becoming more proficient, like any instrument or any tool. And you can see that even though the geometries aren't anything spectacular, that could be data visualization for somebody or some company of sorts that will want you to do that. And the visual artist is going to have a role in that. That's simply how it's going to be. And I firmly believe that. So I'm going to select a few here, and there's the points, and I can just select edit that one. And you get this weird little cloud of things that you can deal with. I'm not doing anything too fancy, and I'm certainly not thinking, oh, I have to start with solids and I have to go into all the transformations that, intersections that join those all together. Like I said, that was my CAD mentality. That was single iterations. That was not parametric. That was not generative. This is where the logic and the algorithms, the logic and the mathematics is replacing the mouse and the keyboard. Whereas I think a lot of people go to the computer tool as sculptors or artists and think, okay, this mouse and keyboard will be simply me picking up a calligraphy pen and working on paper. That's not what it is, and that's really what I want to promote. It's how I've run my classes. It's how I started to follow students, the new generation of people wanting to go places and stay current and be involved in lifelong learning. I'm doing this all on my own time because why not?